Differentiation, lecture number 2. d upon dx of sin x equal to cos x. d upon dx of cos x equal to minus sin x. d upon dx of log x is 1 upon x. d upon dx of a power x equal to a power x log a. d upon dx of tan x gives sec square x. d upon dx of sec x is sec x tan x. d upon dx of cot x is minus cosec square x. d upon dx of cosec x is minus cosec x cot x. These are basic formula. Also, we have studied d upon dx e power x gives e power x. Now, we will study some more techniques. So, d upon dx of sin x is cos x. Now, suppose we replace x by some function, then our question becomes d upon dx of sin f. Here f denotes function, then it will become cos f into d upon dx of f. Example, d upon dx of sine of 2x plus 5. So it will become cos 2x plus 5 times d upon dx of 2x plus 5. And differentiation of 2x plus 5 will give 2. And that 2 we must write in the beginning. Twice of cos 2x plus 5. Take some more examples. d upon dx of sine tan x. It will become cos tan x times d upon dx of tan x. That will give cos tan x times sec square x. Let's continue. d upon dx of sine power nx is equal to n sine n minus 1x times d upon dx of sine x. That is n sine n minus 1x times cos x. Example, d upon dx of sine cube x will become 3 sine square x into d upon dx of sine x, that will give cos x. 3 sine square x into cos x. d upon dx of sine power 7x will become 7 sine power 6x times d upon dx of sine x, that will give cos x. This is true for all functions. So let's write one general formula, d upon dx function power n. So that will be n function n minus 1 into d upon dx of function. Example, d upon dx of tan cube x will become 3 tan square x into d upon dx of tan x, because function is tan x. So it becomes 3 times square x into sec square x. Another example, d upon dx of say cosec x power 5 or cosec power 5x. So it will become 5 cosec power 4x into d upon dx of cosec x, that is minus cosec x cot x. So we write it in the beginning. So minus 5 cosec x cot x times cosec power 4x. Here cosec power 1 and cosec power 4 will become cosec power 5 and times cot x times 5. Now some more questions. D upon dx of function function whole power n. In that case, what will we do? So let's understand it by an example. D upon dx of sine cube 4x plus 5. So we apply same formula. D upon dx of function power n, that is n function n minus 1 into d upon dx of function. But one more step we have to include, and that will be derivative of this. So let's see how. So first we apply this formula. So it will become 3 sine square 4x plus 5 times d upon dx of function. Function is sine 4x plus 5. So sine 4x plus 5. Now sine will become cos. So 3 sine square 4x plus 5, and this will become cos, as we know, d upon dx of sine and then function will become cos function into d upon dx of function. We can also write it in form of block rule that I am going to tell you. Next step. So cos 4x plus 5 times d upon dx of 4x plus 5. So derivative of 4x plus 5 will give 4. So 4 we can write in the beginning. 4 3 are 12. Sine square 4x plus 5 into cos 4x plus 5. So this is this can be converted in another form also, like sine 2x, etc. But that is not necessary. Now let's understand it by block rule. D upon dx of sine block. Block may contain anything, which should be differentiable. If it is constant, in that case, differentiation will become 0. So it will give cos block times d upon dx of block. Example, d upon dx of sine x square. It will become cos x square times d upon dx of x square, and that will be 2x. So we write it in the beginning, 2x cos x square. D upon dx of cos block. Same rule applies, minus sine block times d upon dx of block. Example, d upon dx of cos tan x will become minus sine tan x into d upon dx of tan x. That will be sec square x. So minus sine tan x into sec square x. Let's see some more cases. D upon dx of log x is 1 upon x. Suppose it is d upon dx of log e block, then same rule applies. 1 upon block times d upon dx of block. Example, suppose it is d upon dx of log bc 4x plus 5. So it will become 1 upon 4x plus 5 into d upon dx of 4x plus 5, and the derivative of 4x plus 5 will be 4. So our answer will be 4 divided by 4x plus 5. Another example, d upon dx of 6x squared plus 7x. So d upon dx, this can be taken as block. Then rule is d upon dx of sec block will become sec block tan block times d upon dx of block. So this will become sec 6x squared plus 7x into tan 6x squared plus 7x into derivative of 6x squared plus 7x, and its derivative will be 12x plus 7. That can be written in the beginning. Now some other cases, d upon dx of log x base a. So here we have to change this base a to base e. So for that we can write it d upon dx of log e log x base e times log a. Conversion is log x base a equal to log x base e times log e base a. Also, you will come across such situation where in place of log e base a, it is written as 1 upon log a base. So both are same, the same thing. Who is there? Log e log b base a equal to 1 upon log a base b. Here, this is a constant term. This is differentiable, which gives 1 by x. So our answer will be log e base a times 1 upon x. Another example, d upon dx of log 3x. So this will become d upon dx. First of all, we have to convert this 3 into e. So log e x times log 3e. Log e base 3 is constant, and this is differentiable, which gives 1 upon x. So our answer will be log e base 3 divided by x. D upon dx of log 5x. Here, log x base 5, so this must be converted to log e. So d upon dx of log x base e times log e base 5. That will be equal to log e base 5 divided by x. Thank you for watching.